Hello everyone, it's May the 8th, it's a Saturday. I'm doing it pretty early today because I am afraid it's going to be a difficult one. So I have to get my A game on. Alright, let's take a look what we have. Super palindromes. Super palindromes. Let's say a positive integer is a super palindrome if it is a palindrome and it is also the square of a palindrome. Oh, interesting. Hold on, let me think about it. Left, right. Left, wait, given two positive integers, left and right, represented as a string, return the number of super palindrome integers in the inclusive range. In the inclusive range. 4 to 1000, 4, 9, 121, and 484 are super palindromes. 676 is not, because 26 times 26, 26 is not a palindrome. Okay, so 2, that's 3, single digits always, right? And then 11, 22, that's here. I think 22, yeah. And next one, 33, but 33 squared is larger than 1000. Okay. Oh, and it has to be a palindrome itself. So even if we do 33, it's not gonna pass. Interesting. So super palindrome is going to be a square number that is a palindrome, which is the square of another palindrome. Okay? One and two will be 1. So only digits have leading, they do not have leading zeros. Range 1 to 10 to the 18th. Left is less than or equal to right. Okay, I'm think about it. So 10 to the 18th. Okay, 10 to the 18th. Maybe I can just like count how many palindromes there are and see. But it's 10 to the 18th. There are a lot. I mean, we know it's 10 to the 18th square root, right? Because that's the only thing we can consider. And among them, we pick out all the palindromes, and we're going to try every single one of them to see if it is a palindrome. I mean, palindrome check is easy in Python. It's just one line. Maybe it's fine. Maybe it's fine. Okay, so we have the left and right. I'm going to turn that into actual integer, and we do square root of that integer. So that will find the limit that we can go, and then below that limit, oh man, we have 18, right? 18. So wait, how many are there? How many are there? There are a lot. Like a lot. But no, palindrome, right? So if we find a 2-digit palindrome, the 1-digit palindrome is just 1 is 1 to 1-digit palindrome is a 1 to 9. 2-digit palindrome is a 1 1 2 2 3 3 4 4 all the way to 9 9. Now these are set in stone. 3-digit palindromes will be 1-digit palindrome, and each one and then we have on both sides, right? We rotate, and then we get all 3 digits. And the 4 digits will be the 2-digit palindrome in the center, and then the other one. And the 5 digits will be 3 digits plus 2. 6 digits will be 4 digits plus 2, right? So we can, it is possible to iterate, but there are a lot, right? I mean, if you think about it, 1-digit palindrome is 9. 2 digits palindrome, 11 to 99, is also 9. 3-digit palindrome will be 1-digit palindrome with 9 numbers, and then each one of them we can fit 1 to 9, right? So that's 9 times 9. And 4-digit palindrome is 9 times 9 as well. 5 digits will be 3, so it's 9 to the 3rd. And 6 digits was also 9 to the 3rd. And then 9 to the 4th. So there's a lot to check, and every single one of them we have to do, well, is there an easier way to do this? That's the thing, is there an easier way to do this? And we only need to return the total number. I mean, we can produce all of them, but all right. So let's think about it this way. To be, now it could be anything, and definitely we cannot just do. I mean, we can square root them, right? Square root them. So we're looking at 10 to the 18th. 10 to the 18th is the largest, and we square root that as 10 to the 9, right? 10 to the 9. So we have 9 digits. Well, 10 to the 9th. Yeah, 10 to the 9th is not so. 10 to the 9th is 10 digits. So the majority. So we're going to handle the maximum 9 digits. So 9 digits. If we keep going, 7 digits is 9 to the 4th. 8 digits is also 9 to the 4th. 9 digits, 9 to the 5th. Let's see how many there are. 9 to the 5th is 59,000. So 59,000 numbers. I mean, adding together the total number we have to check. So basically it's 2 times 9 plus 9 squared plus 9 to the 3rd plus 9 to the 4th, then plus 9 to the 5th. We actually calculate how many we have to check. Squared, 3rd, 4th, right? Oh, okay. It's not that much. Times 2 plus 9 to the 5th. 73,000. That's the total number we have to check. The maximum number we have to check. It's possible, right? Yeah, it is possible. It's not that much. It's a maximum. Like we're talking about maximum of 73,000 checks, and each check we just square it, and then see if it's a palindrome. I mean, if it's a palindrome, the palindrome will be maximum 18 digits. So basically it's 01, right? So yeah, I think we can just brute force it. I mean, unless we brute force it first, and if we have any issues with brute force, then we'll probably time out. But let's try it first, just brute force. I kind of think it shall work, because it's not that much. It's not like, we're not talking about hundreds of thousands, right? We're talking about just 73K, which is fine. I think it's fine. Okay, logic to run. Okay, left or right. We need to know the left. Well, we're gonna start from what? Well, depending on the left. I mean, no matter what, we have to. Yeah, no matter what, like even if the left is say a gigantic number, right? If the left is a gigantic number, then to compute the possible palindrome, we still have to do all of these things, right? We still have to do all of these things. But there's one thing. So I'm gonna say lint right int equals int left int right, and I think we also need to import math because we want to do sqrt, and we're gonna say limit equals sqrt math.sqrt r int plus 1. So we're gonna int it. I don't have the plus 1, just int it, right? So this is the limit. This is the limit. Cannot be larger than this, right? So we can say, right? We can say if left integer is large than the limit, then return 0 because it's impossible, right? If it's not large, then we need to find all palindromes from left int to the limit, all the palindromes in it, and then we need to check each one of them and then do it. There's one trick that we can use because the total number of palindromes are set in stone, right? They're set in stone. So we can actually get everybody, right? Get everybody. How do we get everybody? How do we get everybody? I mean, if we can produce a palindrome like here, right? We do something here. Is it possible? We say palindromes, right, equals a dictionary. Right, a dictionary, and what? Palindromes is going to be a dictionary, and we need to run if not self.palindrome. Then we create the palindrome, right? We create the palindrome. How do we create a palindrome? We say palindromes 0, right? Actually, it's we can make it. Yeah, that's just a dictionary. That's fine. Not 0, 1, which means a 1 digit in length. That's gonna be list range 1 to 10, right? And then palindromes 2 is going to be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. Right? So these are set in stone. Now from palindrome 3, we're going to go all the way to palindrome 9. We'll just create it once. Can we? We actually can. No, let's do it. Let's not do it this way. I always want to try this idea. Might mean something. Yeah, let's just do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And then this we already have on line 20. Actually, line 19. Okay, we're gonna say okay. Oh no, that's not the one I want. This is the one I want. So this is the starting point, right? So what I want is incrementally build up the palindrome, right? So basically we want to see, okay, what do we want to see? We want to see what's the left int, how many digits there are in the left int, right? I'm going to say if the number of digits in the left int, that number is already included in the palindromes, then we can do it, right? Yeah, we just say, oh, how do we do this? Oh, this is getting a bit exciting. We have the number, right? And then we say if that is already in palindrome, right? If it's not in palindrome, so we say if len left, right? Left is this. So if len left is in self.palindrome, is not in, then we have to go from 3, right, all the way to, then we say num of digit, right? We're going to start with 3, and then we say while num of digit is smaller or equal to len left, because if it hit the len left and then do it one more time, and then when we large and then we don't do it anymore, right? Hold on. No. Wait, what are we doing? What are we doing? What we want to do is, if the digits does not exist, then we create it. If it does exist, we use whatever we have. And actually, this is the palindromes, right? We should also have another one. Yeah, we should have another one that, you know, we have a palindrome that want to build up every time. We should have another one that is super, right? Super palindromes. Just an empty to start with. So this one shall record the number, right? Not number, it shall record what they are. Super palindrome. No, I'm a little bit confused on how what we want is a super palindrome. So this is super palindrome. It's not super palindrome. It's the value. It's the base that can lead to super palindrome, right? The base that can lead to super palindrome. So we can say bases, number of bases, right? With 1 digit, 2 digit, 3 digits, and what we're going to do here is going to be what is it going to be? So we have the left, so we know the number of digits, right? Then what we want is to, hold on, left is starting point, right? Left is the starting point. So we have to go something lower than left. We should start from something lower than left. So to search from the start. Hold on. If we can have the palindrome because I try to build it incrementally, right? I don't want to build it from the start. I want to build it incrementally. So give me a value, then I compute just as much as I need to finish your task. The next one, if I need to compute more, I compute more. So you give me a value, but I don't know like from where I need to start, right? You give me a 3 digits, like any digits, then what? Then I should also take the square root of that as well. So we have a lower limit and then we have a higher limit on the base, right? On the base, the lower limit and the higher limit on the base. Right? Lower limit is going to be the left, take a square root, and plus 1. That's the lower limit. And we also have higher limit. So we have the limit on the base. Yes, I think we do need a lower limit, a left limit, and a right limit. So that's going to be int math.square root left int plus 1, right? That's the left limit. So we're going to work with left limit and right limit. Now, of course, if the left int is larger than the right limit, right? So these are the things that we can do the square root. That's actually no, because what we want to find is the super palindromes. So that's not the case. But if no, it's not. It's fine. This does not exist because what we need to compare is the left limit and the right limit. So if the left limit is larger than the right limit, then it's not going to happen. But here it's going to happen. We have a left limit and a right limit, right? So this is just the base, right? The left base limit and the right base limit. Now, what we want is we have the left limit, and we don't know how many digits they are, right? And once we know the number of digits the left limit have, and we only see if the palindromes, I don't want to call it palindrome, this is going to be bases, right? And this is going to be super palindromes, right? So we have the base and we have the super palindromes. What we want to do now is oh, but the values will not be sorted. Like I was thinking about get the super palindromes in it, and then we just create a list. But then if we do that, if we do create a list, I mean, there won't be that many in it, I think. We'll create a list, and after we create it, we basically just sort it. Hold on. If we create it once, we want to create it only once, right? That's what we want. Create it only once. So we have the left limit with the right limit, right? And then the left limit, we need to find the basis, and we check the number of digits on the left limit, right? And then if the digits that we have found already, then we use that to populate the super palindromes, right? Yeah, we populate the super palindromes, and or should we let's just like do it once, right? We'll just do it once. I mean, no, I want to do it incrementally. I really want to do it incrementally. So the input left limit, we have a number of digits. and we need to first find so we need to find all the palindromes that satisfy those number of digits, right? And then we're going to go through the number of digits, but then the super palindrome is not going to be well populated. Interesting. So how about we just populate the bases based on the number of digits we have on the left limit and the right limit. Right? We don't even care. We don't even care the left limit or right limit, like what they are. We don't care. We just want to know the number of digits. And then we populate the bases, right? And then for those bases, we find the super palindromes, right? And then we populate the super palindromes. And then we're going to find from left and right, we're going to count how many are in each one of them. And then we have a result. Okay, that's a thought. So in this case, we have the left limit, right? Mass strt int +1 and len and the len right limit. So we're going to turn it into str, right? I'll turn str, and then after we turn str, we're going to also do len, right? It's the same. So we len str, then boom and boom. Right, so this we have the length on both lengths, and we say for digit for num digit in range len left limit to len right limit, right? If not if what we're going to do is, if num digit is not in self.basis, right? If it's not in basis, then we need to work on it. How do we work on it? Well, well, if it's not in, then we have to go from the start to work all the way towards the current num digit. So I'm going to say for I in range 1, 2, it's actually not 1, 3, because 1 and 2 is already there. So 3 to num digit, right? Num digit +1. Then for I the num digit, so we got I minus 2 is the one we're going to use, and I'm going to take every one out of that, and I'm going to append on the front and the back. Okay, so what we're going to say is self.basis I, right? So the basis I is going to equal to a list which is for j in range 1 to 10, for the middle part in self.basis I minus 2, right? Self.basis I minus 2. Self.basis I is the current number of digits minus 2, so we find whatever it is, and we're going to append it. What we're going to do is, hold on, we're almost there. What are we going to do? So it's going to be it is going to be mid times 10 plus j times 10 to the what power? 10 to the ith power, because of the 3, when the 10 to the 3, no, it's going to be I minus 1 power, because if it's 3, we want to do times 100, j times 100, so it's second power. Mid is going to be this, right? And plus j. Okay, so that's that. So this is from 3 to num digits. So after that, we have num digits. So for num digit in range this, if num digit not in self.basis, we create num digit, right? After we create the num digit, so each num digit we created. After we create it, so it's in self.basis. Now we need to create the super palindromes for this whole num digits, right? So we're gonna say, how do we know that it is populated? Oh, we actually don't know. We don't know. So actually, I think we need to count based on basis, not count based on super palindrome, because the idea is for the number of digits, and the number of digits we're using are the bases. But if we count based on super palindromes, we don't know, right? It could be, if we have 3 digits to start with, we can have 111 is this is 5, and we can have, well, it's actually not possible. If we have 5, it's always 3, right? Hold on. 3 digits. How about 4? 4 digits will go to 1, 2, 3, 4, 5, 6, 7. What if 6? Right? It's also 3 of 4. No. No, I don't think so. So we have the base, right? So num digit not in self.this. Then from 3, oh, I have to do one more. Let's say if I not in self.basis, then we do this. All right, so we skip the one that we've done already. So just do the one that we haven't done. So basically, we just sweep it. Right, we sweep it. Hold on. We guaranteed, right? We guaranteed, as long as we run once, we guaranteed. So we can actually start from the largest in the base. So it's not gonna be here. We know that's always gonna be the largest. So we're gonna say max self.basis.keys, right? Plus 1. Right? Then we don't have to check this, and we know it has never been done before. So from here, go all the way. So now we have num digit. Now we're gonna check the num digit, and then we just say, like for the base is this base. We're gonna list the values. Yes, so we're gonna say a good base, right? Good bases. So we have num of digits, then we just loop through the num digits. I'm going to say for base in self.basis num digit, right? Because num digit is not in self.basis. If it's not in self.basis, that means it's not in self.good basis. Does that mean you have to do this as well? I mean, I already give it to you, right? I already give it to you. So we know if it's 1, right? It's going to be 1, 2, 3, 4, 1, 2, 3, right? 1, 2, 3 are the ones, right? And then we don't have anything. I only say 2 digits. 2 digits. We have 10, 11, right? 11 is right here. 11 and 22. And actually, we don't know. We can actually check. 33. No. 44. Ah. So I think let's just keep it. Let's just keep it like this, right? So, I mean, we can hand calculate some, like 55 is a no. 66 is a no. 77. No. 88. That's not a palindrome. 7744 is not a palindrome. 99. No, that's it. So it's just 11 and 12. Like all the other, it's just, let me double check. 33, 44, 55, 66, 77, 88, 99. I mean, all right. Well, but we can't. Yeah, let's just do, okay, these two, done. So these are the this. So, which means if num digits is not in self.basis, then it's guaranteed that it's also not in self.good basis. So if it's not in there, we compute it, right? And then we try to do it in here. If num is not in self.basis, let's just make sure. If num digit not in self.good basis as well. Now we're gonna try to do this. So we say base in self.basis num digit. So we just every single one of these, and we say squared equals base, right? Squared is this, and no, we don't need the square. We just need to see if no, we do need this. We do need this. Squared is this, right? And then we say if oh, that is not a. We have to set it first. This is not a default dict. Same here. So it's also not basis, self.basis. It's gonna be self.good basis equal I. Num digit equals this. Right, so if num is not in this, and then for I, actually, oh, this is fine. We don't have to. This is directly do it. Oh, we can do this too. If num digit, what do you append then? Right? Here I can append everything. Like if it doesn't, then we don't append anything. So we have to do this, and we say str squared. Str squared. Okay. So the str this. So we say if str squared equals to str squared, I think that's square squard, right? Qard, okay. This equals, that's palindrome. If this is that, so self.good basis num digit dot append what? append the base. Append the base, right? So say if num digits is not in this, we're gonna go through all the bases, right? We go through all the bases and then we put the right ones inside. And when we do this, there's actually no concern on the size, right? There's no concern on the size because we just do the number of digits, right? Is that the right way to think about it? Because we have the right, and then we do the square root of it, and after we do the square root of it, we get, no, we actually need it. We actually need it. So yeah, we actually need a limit. We do need a limit. I mean, we when we populate these, we don't need a limit, but eventually we do need a limit. So these has to change, unfortunately. So we have to delete that, and I think just go here, delete these two. So we do need the left and the right limit, but here is just going to be len str left limit. I just call log on it. That's fine. And this is going to be len str right limit plus 1. So this is just to get the total range, right? So what we're doing a total range. That's for each number of digits. We get its base, and after we get a base, we try to look it into the good bases, right? And then once we find a good base, we append the base if it is a palindrome. So we go through everything in the base afterwards. So this is just to populate it. But if we are already in it, then that's fine, right? Then that's fine. Then what do we do? Right? Then what do we do? Then we say we have the result. So we're gonna go to line 18. That's not what we want. That's what we want. So we're gonna say res is 0, right? Then we go back down to len 30. So here, what we do is we populate. So num digit is in it. Now we didn't know how many there are, so we can use our trusted from bisect import what? If it's the same, I want to insert on the left side. So we say bisect left, right? Let's try bisect left. So we go to line 30 as well. No, actually, yeah, 30. So now we can do bisect, right? So we can say when we run bisect, so we run bisect left on what? On self.good basis, num digit, right? That's the array sorted, and then we put our left limit into it. No, no, it depends. It depends. It depends on, would probably, yeah, the num digit, if it's inside, then it would behave differently if it's outside. So we also need, oh my god, len L, actually len R. Let's do that. So we're gonna say, I'm gonna come in here. We're gonna copy the whole thing. Hold on. Go here. We're gonna go with this. E. Okay. So I'm gonna yank it and go up. Paste it. Right. And then coming here, we shouldn't have yanked it. We should have just deleted. We can use C. Yeah, should have used C on this. Anyway, so it's gonna be len left, len right. Okay. Now, want to say, that's right here, if num digit, like if num digit is equal to len left, right, then res plus equal to, I'm going to bisect on num digit and want to do left limit, right, left limit. And if it's the same, if it's not the same, we're going to end up at in the middle. So we're going to say it's the length minus my digit, right? Let me just write it out. 2, 3, 0, 2. So if I go to, say, a number in between, which will end up on the next one. Oh, no, yes. And well, next one, right? So the total number is 3 minus 2 equals 1. So that's the number of one we can get. Yep. Because the total number will be this minus this plus 1, which is total length minus your index. So if it's the same, if we're on the same one, and then we insert front, which means we just insert on that one itself, so including it. Like it's 2, and we say it's going to be 1, right? 1, 3 minus 1 is 2. So yeah, so it's going to be len. So bisect this will give us the, so we're going to say len self dot good basis num digit minus, right, more explicit, minus this, and if it's this, I'm going to say aleph equals len right, and then minus can be no. Then it's not because it's going to be not minus, because the minus is taking the right side. Now we're going to take the left side, so it's going to be bisect left to the right limit, right? So we have the right limit, and what we want to find is until right limit how many there are, and we're doing it pushing here, which means it's this, which means we're going to go this. We need to use bisect right. Yeah, we need to use bisect right, so we have to go, I think, both bisect left and bisect right to make it easier. So actually I just realized we can do rlim plus 1. That's bisect right. Let's do that. So instead of doing bisect right, we can use bisect left, but just be a little bit trickier. Instead of doing this, we can do plus 1, right? When we do plus 1, it's always ending on the next. If we do plus 1, we're always ending on the next one, and if it's the same, we'll always be on this. If it's not, then it's fine. So yes. So yeah, that's it. That's gonna be oh, what am I doing? If I kind of see what I was where I was going for. Yeah. So I just want to delete this one. So bisect left, and we're gonna say right limit plus 1. Right limit plus 1. That's the total number of that's before. Okay, so that's that. Else if num digits is in between the two ends, right? It's in between the two ends, then we say res plus equal to just len self dot good basis num digits. And then we just return res. And as we go through this, right? As we go through this, this table will be these two will be populated more and more. So we're gonna go through this and we're gonna check if they're already done. They're already done. We don't do it again. We directly run this. Okay, let's try the test cases. We'll see. We'll see how this one goes. It'll be interesting. So first one we have a 4, and we have a 1000, and result is 4. Second one we have a 1 and a 2, result is 1. Right? And we have here is going to be a left, a right, and oh, we're going to do CE here. Super this left and right. Fail and fail. Ha! Okay, okay, that's a blow. That's fine. That's fine. Doesn't matter. Let's just before we return, let's print out basis, and let's print out the good basis, right? Self. Okay, so basis, we have 1 digit. This is 1000. 1000 should give us 2 digits. Yeah, so it's 2 digits. So we have 1 digit and 2 digits. All right, and it's init. 1 digit's init, and 1 digit is also init. So it could right come here. So number of digits equal to 1. Yes. Then we need to see bisect left self dot good. Good is here. Number of digits 1. Left limit. And we need a left limit. Right? Let's just print out left limit and a right limit. See if they make sense. 3 and 31. That does not make sense. How is the left limit 3? Because you plus 1. That's why. Okay, left limit, do we plus 1? Because what I think is, if we get a fraction number, like when we do int, and a square root, then it's not going to work. Okay, what we want is ceiling, right? I think, let's try. I think is ceiling. Math dot. I think we have ceiling. Import math. Math dot ceiling. Yeah, we do. We do have ceiling. So 2 is going to be 2. 2.1 is going to be 3. Yes, that's what we want. So it's not int, right? Left limit is not int. This is going to be math dot ceiling. So I don't have to handle this. And this is going to be floor, I think. So 2.1, if we say floor, it's going to be 2. Yes. This will be math dot floor. And we don't need int because it does int for us. So ceiling on the floor, and then we pass, right? Okay. Comment it out. Let's go down. Okay, so this one. Okay, now the second one we fail. All right, that's fine. Let's take a look. What happened here? 101. Well, the result is 3. So 101 coming in. Num digit is 1. 1 is in, 1 is in. So num digit is equal to 1. And num digit is also equal to this. But it's aleph, so we should only do once, do here, and then we don't do anything else. And then we say res equal to len this is going to be 3, right? And we have is 1. Left limit is 1. So bisect 1. Oh, right is on it too. Holy moly. Holy moly. If they are the same, that's a different scenario. Yes, we are not considering, okay, so it's this. So if they're the same, right? Because len left is definitely, hold a sec. Because we are doing this num digit 1 by 1, and each one we compute the result. So if they're on the same, then we're only going once, right? Otherwise, we'll always go multiple times. So in a check, yeah, we have to check. Basically, the check has to be what? If num digit equals to len left and num digit equal to len right, which means these two are the same. If they're the same, then res plus equal to, it has to be in between, right? So it's going to be bisect So the right limit, the left limit, so going to be bisect left. Man, it's to the left or to the right? It's going to be here. Yeah, so it's going to be bisect right. Yeah, it's going to be bisect right. And what of the same? No, it's not bisect right. It's bisect left. Bisect left because we want to include it. Bisect left. So it's going to be bisect left. This, I'll copy the whole thing. So it's be bisect left this, right? And then we're going to do another bisect left. Basically, it's this thing, right? We're going to do bisect left this thing, which will get us to the end, right? Do you want bisect left or bisect right? No, it's actually also going to be bisect left because it's fine. If bisect right, then we just don't plus 1. So just this. Yeah, so if it's the same, we do this. Aleph, which means they're not the same, right? Aleph, which means they're not the same, then we say if this equals this, okay, this one pass. Okay, let's run a few more. Let's run a few more. It's kind of complicated. I bet there's a better way to do this. It just look marvelously convoluted. Let's see if we can like add a few things to. Look at this. Oh, it's super long. Super duper long. Anyway, let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So run it. Let's see how long it's going to take. Your answer is 10. Expect answer is 20. Okay, it's not correct. All right, let's test this one. Let's see, how many are we looking for? Oh, this is actually correct. Okay. Let's do this. No, it's good. So we say, yeah, we just keep adding test cases. 1, 2, 3, 4 is going to be 4. That's not challenging. How about this? Yep, here we go. Now we have an error. Okay, so 4, 1, 2, 3, 4, 5. Supposed to be 9, but I get a wrong answer. Again, we need to print. Why do you delete it? We need right limit, and then we also need self.basis and print self.goodBasis, right? And we run this. Okay. Let's see. Result is 9, but I don't get 9. So we're gonna start from 2. Oh, I don't even have 1, 2, 3, 4, 5, 6, 7, 8. I only have 8 in total. I only have 8 in total. But the result is 9. And we have to 316, right? That's the left and right limit. 316, yeah, 316 is correct. So we're miscounting. We missed a few. 111, 121, 212. Where are the 9? I have 2 more. Is it in the 3 digits, right? Is it in the 3 digits or in the... I don't know. For I in range, I don't care. So we just say yeah, so 4 to 16, 25, 36, 49, 64, 81. No, none of these are good. So I'm going to say from 10 to 100, right? And we say str squared equals I times I, and if str squared equals str squared reverse, then we print I and str squared. Int object is not subscriptable. Yet of course it's not, because we forgot to do str. $26. You missed 26? How? Oh wait, no, the base has to be, right? The base has to be palindrome as well. Yeah, the base has to be palindrome as well. So we didn't miss. Yeah, 26. No, we didn't miss. And now let's do the 3 digits. Did we miss anything? Yeah? Oh, the zeros. Aye. We forgot the zeros. No. No. Oh my god. I forgot the zeros. Ah. Okay. Put zeros here. It's fine, right? It's fine because zero would never be considered. We just need to put zero in everything. Uh, yeah, zero has to be put in every single one of these. Good bases. Zero is a good base, but we don't include it. We won't. Will we include it? I mean, we can include it, but it's fine. It's not gonna be affecting. No, no, no. We cannot include because we will count zero. We don't want to count zero, but we have to put zero here, which is fine. But when we push into, right, it's gonna be this. If 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 str squared is not equal to zero, but we have to do zero. Yeah, I forgot about zero. That's sure. And this. That's it. All right, that's it. So comment out this. I forgot about zero. I mean, I don't think this is a hard question. It took me so long. This one's good. Keep adding. Run code. Okay. Let's add more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, what else did you forget? Mamma mia. 12. Okay, so this is the wrong one. All right, take a look. Okay, 4. I mean, at this point, I just want to do everything like from scratch. Try to build it up. Like, man, this is very frustrating. All right, let's see what else. I mean, we do all the 3s, right? Let's do all the 4s. Just add one more 0. Oh, nope. Oh, we did miss. 2002. No, we did not miss. That's good. 5. 5. 5. Okay, we have 1. Oh, we missed a 0 again? How? How did we miss the 0 again? Oh, we missed the 0 here. Dear Lord. Yeah, so... ma, 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 ma. 0 to 10. That's the thing, I think. Yes, now we have everything. We missed the zeros. Okay. And I think we can just change here. So where is it? So just range 10. Alright. I'm gonna keep adding. I don't even know how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I have confidence now. Let's try it. Yep, got it. I mean, it's not a hard question. It's just I don't know. Okay, honestly, I don't know if we just do everything without caching, right? It probably can work as well. But I did cache, but actually the difficulty is not about caching. The caching is just you write this. You have to do all these things anyway, right? So it's just how to create future palindromes on larger digits based on the ones you already have, and we blundered. We definitely blundered on this. Yeah, we have to do zero as well, and we cannot include zero here. So these are the blunder we have. Oh, and also this. We have a bunch of blunders, but it took us a good hour to finish this. I want to see how the correct version is. I don't think this is the correct solution though. I mean, okay. This solution is very straightforward. We find the base. We find all the palindrome bases first, compute their squares, and record which base can produce a super palindrome. And we record all of this information as cache. Maybe there's another way, like left and right. Like a range, right? We have a left and right, we have a range. And then based on this range, and if you increase on the right a little bit, it's not going to change the value. It's only have to increase a large amount. Then you have to change the value. That hurts my brain. I record all of this information as cache. The trick lies in how to produce a palindrome of higher number of digits based on lower number of digits, based on palindromes already created in lower number of digits. The one that I blundered on is that I forgot to include 0. Another trick is to consider that the base for left and right can have the same number of digits. Once these two hurdles are cleared, we're good to go. All right, took us a good amount of time. I don't know what's the runtime. Let's take a look. Oh my god. Oh, hold on. Our runtime is 288 milliseconds. And what we have here, I'm here. I'm 94%. I guess the caching, yes, because of caching. I guess the majority don't cache. I don't know. We use cache heavily, which lands us at 288 milliseconds, which gives us a 94% ranking. I mean, this is just a trick, right? A trick of using cache. Oh, so we can do this. Wow, look at this. The time limit set You can do it at 8 seconds. They still accept it. But look at my memory usage. Yeah, so the memory usage is horrendous. Memory usage is 7% ranking, which I mean it's a trade, right? It's a trade-off. I trade memory for trade the speed for memory. All right, let's go back and take a look at the solution. Yeah, I think it's a medium. It's not going to be easy. It's going to be a medium. Oh, it's labeled as hard. I like it. I like it. I don't know why people don't like it. Oh man, there's a math solution. Huh? 1 is a super palindrome. Hold on. Block W. Magic odd length is palindrome. Reverse. Wait. Say P is a super palindrome because R is a palindrome. The first half of the digits in R determine R up to 2 possibilities. We can iterate through these digits. Let K be the first half of the digits R, for example, that R equals this or R equals this. Okay. Each possibility has either an odd or an even number of digits in R. Notice because this R is smaller than 10 to the 9th and R equals K concatenation, but K is K reversed and also possibly truncated by 1 digit, so that K is smaller than 10 to the 5th, our magic constant. R is going to be 10 to the 9th. R equals K, and then K prime concatenate. Yes, 10 to the 5th. R smaller P, so R, yeah, R is 10 to the 9th, so K is 10 to the 5th. Okay, for each K, let's create an associated palindrome R and check whether R squared is a palindrome. I like to break early so as not to do extra work. Okay, so we have the magic. Odd length. Odd length is we remove 1, okay. If V larger than R, then break, yeah. Yeah, oh, okay. All right. Oh, I like that, I like it. Yeah, this is the one that I do. Yeah, I mean, it is also possible, I think. We don't even need to do we need 2? Oh, we don't need 2. Because of 0, I think we can even comment out this. And key error. Key error, of course key error, because we have to oh no, why do we have key error? and base I minus 2. Ah, because we don't have, we need a 0, right? We need a 0. Hold on. What? How we compute it? So for the mid, and we don't have a mid, right? We don't have a mid. No, we don't have a mid. So if I is 2, right? So we need a mid. It's just going to be 0. Or for mid. Yeah. We don't need a 2. I don't think we need 2, but we do need 0 though. We do need 0. This is necessary to compute 2 digits. Right. And then, okay, let's break it down a little bit. This is super long, and that's good. Let's break this down, so make it look nicer. Ah, it's fine. It's just super long. It's fine. We can post it actually, I think. Backtracking. Is that considered backtracking? I don't know. Math solution. Yeah, we're gonna try that math solution, but we can post something. When I say use cache, build up a cache to speed up. Build up a cache of good base palindromes. Now we just copy and paste the code. Oh, it's for a contest. Oh, it'll take a long time. Hi, I think it's fine. I can do this for context. Figure squares and record which base can produce a superpalindrome and record all of this information as cache. How to produce palindrome with higher number of digits based on palindromes already created in a lower number of digits. The one that I blundered on that I forgot to input 0. So consider that the base for left and right can have the same number of digits. I want to add a little bit more comments in here. So this is left and right. Base left base limit and right base limit. If current number of digit has not been create list all palindromes, list all palindrome, create all palindrome, generate all palindrome, generate all palindromes with num digit palindromes that have length of number of digits. If it is not in the cache. And I'm going to say these two cache for all palindromes of different number of digits. Different number of digits, palindrome of different number of digits, palindrome of all of different number of digits. And this is cache for the palindromes that can produce super palindromes. Cache for the palindromes of different number of digits that can produce super palindromes. We obtain the solution by counting this bit, right? So if it is not in the cache, have a length of if it is not in the cache, right? And then this one is loop through all the palindrome base of num digit in length and identify which ones can produce super palindrome. Save the eligible ones in the good basis cache. And this is counting. Count the number of good bases based on the current number of digits under consideration and the left and right base limits. Yep, I think this is a better one to explain. Alright, I'm going to do that again. I think with this, there's no need for me to write anything. The use of cache significantly speeds up runtime at the cost of memory usage, of course. Right? I can post it. Yep. Just for fun. Oh, look at this. Super long. All right. Let's go try the so-called math solution. Yeah, I don't think it's a math solution. It's just it's a regular solution. It's a regular solution. I don't see that as a math solution, to be honest. But basically, this is just to iterate through all the palindromes, right? All the values, I think. It's all the values. So this is going to be, this is the official solution. This is the official solution. Which is dubbed as math solution. However, I do not see this as a math solution. It's just a smart method to compute palindromes directly, iteratively. I mean, ours is also directly. That is, without the need to save previous palindromes. Okay, so the idea is neat, very neat idea. So we just need to find a total number of halves, right? The largest half of a base palindrome is 10 to the 18th. Is this QRT? 10 to the 18th. That's the largest. 10 to the 9. That's the largest base. And 10 to the 9 when divided by 2, which also is QRT, right? And then we also is QRT this, which give us 10 to the 9th, right? 10 to the 9th, if we SQRT this, give us its 5 digits. Well, actually it's not, because 9 digits, right, is this, right, which has 9 digits. Thus, the largest half, the largest base palindrome. So the largest half of the base, the half of the largest base palindrome has 5 digits, which makes it 5 digits, and it has 5 digits and is an odd palindrome. Thus, we loop through all values up to 10 to the 5th and check for palindromes. Check for super palindromes. As well. Actually, this one, I think it actually fits above. It fits here. Right. When I say we can definitely build a cache for this as well, but let's not do that. All right, so I'm going to say, what do we say? Rest equals to 0, and for half in range from 1 all the way to 10,000, right? And we're going to say is, and let's also not stop early, because it's fine. It won't cost too much. So we're gonna say odd palindrome base. Right? What's the odd palindrome base? It's gonna be odd. Odd p equals half plus str half plus str half, and then we're going to reverse it. Actually, no. We just don't include the last one, then reverse it. This is odd. And then we say odd square equals str, odd square, str, int, odd p, do this, and if str odd equals to str, this, minus 1, rest plus 1. Now, the exact same thing. We can just reverse it. Minus 2. I think this is the trick. Right? From minus 2 to the end. From minus 2 to the end, but we reverse it. I see why you use this. And this is basically just recursive. So half plus half, so it's not odd. So odd, we're going to change that into even palindrome. And if this is, and then rest plus equal 1, right? And return the rest. And now let's try solution 2. Oh yo, this is terrible. Oh yeah, because you can't do this. You have to get out. You have to get out, man. You have to get out. Oh, now I see. Now I see the point. Now I see the point. Oh. And we have to consider left as well. Oh man. So we have to do, dang it. So we have to do odd square equals to int odd p this, right? And we say if odd square is smaller than left, I'm gonna continue. If odd square is larger than right, I'm gonna break. And then we do our regular business, right? Odd square, and we do this. Okay, so the same thing has to happen to the other one as well. That's fine, just 2 loops, range 1 to 10,000, and we produce this, and we just, do the odd into even. 2 rounds. Try it. Left has to be int, so we can handle the right at the same time as well. So right int even squared. No, it didn't do even squared. Jeez. Even squared equals to this. And then this is going to be even squared. And then we're going to use it many times, so we're going to just call it L int right int. We like to do that. Int left and int right. So I don't want to call it every single time. So all this is going to be L int, and all this is going to be L right int. Rint. Hey, we still have fail. The last one. How? 10 to the 5th. It's 10 to the 4th. Okay, we need another one. What's that? Half limit is 10 to the 5th. So instead of do this, we're going to say half limit. No, we can't have five digits. Yes, 10 to the 5th is 6 digits, so 5 digits. That is true. Okay. Then it's still not right. We want to have 5 digits, right? 1, 2, 3, 4. 10 to the 5th is 6 digits. right? 1, 2, 3, 4, 5. That's for half. Small left end. It has a larger the right end. Then we break. Is it because the half is not correct? If it's 6 digit, then no, it cannot be 60. It has to be 5 digits. Will give us to 9 digits, and then we get to 18 digits, 19 digits, 18 digits. Oh, what is it? Something is missing. I want to debug, or you want to just check the result, kind of see what is missing. Honestly, I don't understand. Let's print it out. Yeah, let's print it out. Because there's not that many. We can check, see which one we miss. No, we just want the last one. Okay, so this is what we found, right? Syntax error. And we need a we need this. Oh no. I think we can say is cancel. Oh. Is this new? No. Wait, I don't understand. Find replace. So it's a alt. And then we can do this trick. And then we can go to here. A.sort. Okay, now we're gonna swap to solution 1, and we're gonna print self.goodBasis. Okay, so that's what we have. Yeah, we can actually just do it here. It's not too hard. So we just find all of these and delete, right? And we're gonna find all of these, delete, and we're gonna find all of these, delete. I still have this. Interesting. Okay, so I'm gonna go to here. Oh, let's say math.sqrt a not an int. Let's just do math dot. No, this is bonkers. Ceiling. Yeah, and ceiling. I for I in A. Okay, and then no, that's not the one. Hey, we are missing a few. Slice. I'm cutting a little bit smaller stripes and slice it. Hold on, this is not right. This is the one that we're looking for, but this is the one that we got our results. Something is not right. Let's see it again. Right? We start from 1. And but how do we print? Actually, let's print math.sqrt directly here. Add this, right? And then say math. I'm actually not going to print math.sqrt because these are all palindrome, that's for sure. I'm going to print out just odd and even p. You see, we have 2, 6, 3, 6. What the hell is that? That doesn't make any sense. Probably is this one is messing around. All right, so a equals 1, 1, 2, 3, 4. All right. A plus A there we go. That's the problem. So minus 1? No. What? A. Hold on. If we do this, that's the entire thing, but we don't want to do the entire thing. So we say it's going to start at 0, 1, minus 1. If we do minus 1, that's nothing, right? The minus 2, minus 3. Oh, it's 0, 1. No. 2. There we go. So how does this work? It starts from 0, 1, 2. I say from 2 to the end, but we're going to reverse it. So it'll be 3, 2, 1. Oh, okay, got it. Now minus 2 is plus 2. And this time we shall pass. There we go. Now we pass. Okay, that's that. That's that. And we also don't need this one. And try the other one. Oh yeah, now the other one failed. What the hell? Is that not right? Oh, this 2 minus 1. I don't think that should be 2 to this, then the -1. Wait. What is this? How is this? What the heck? Like, seriously, what the heck? I didn't expect this method to give us so much trouble. Oh, now we have more issues. They're the same. They're all where are the odd ones? Half. Isn't this? Huh? Hey, what the hell? Half? Let's print out half and print out odd p. We don't even need to print these out. I think it's still... Yeah! That's not correct. That is not correct. Hold on. So what you're saying is if A equals, what, 1, 1? Not 1, 1. Let's do 1, 0. So nope. Nope, that's not it. And what, -2? Oh, it is -2. Okay, if it's 0, 1, 2, then we go to -2. Yes, it's this. Still need more practice on this, the splicing. This one should be right. There we go. This one is correct. It's a -2, -2 to -1. If you think about it, -2, because what we want is to eliminate the last digit. So that's -1. So go to the -2, the second one from the last, and then go -1 from this one going backwards. How did I mess this up? There we go. Now we have it. All right. Submit this, and that's it for today. Man, my throat hurts. Not bad. Not bad at all. Caching, make it faster. That makes sense. All right, that's it. That's it for today. Well, I spent a lot of time. 2 hours. I mean, honestly, I don't think it's really a hard one. I mean, because if you even using this method without caching, I think we can still pass. So it's just how to build the palindrome, like in a smart way, and that's all it is about. All right, that's it. That's it for today. Adios.